Hello and welcome to the relearning for area, perimeter, circumference on a graph. This is the second standard for Unit 4. Please put the date that you've taken this relearning as well as your name on here so you can get credit for it. If you're watching at home, you can use a sheet of paper and follow along and hand that in to me, or you can go to the room 1029 in the back. There's a blue compartment and you may use that. There's a paper in there that you can follow along with this right here and then hand that in for the relearning. Once you're done with that and you give it to me, we can take a look and we can do the reassessment right after that. There are three main compartments with this. This is like the sister standard for the area, perimeter, and circumference. They're very, very similar. The only part on this is you're going to have to find some of the information yourself. So if we take a look at this problem here, which should look familiar, we've used it several different times, but I'm going to ask you, when we're looking at perimeter, we're interested in the area, or excuse me, the line length that are on the outside of our figure, these lengths, here, 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 and here. That's what we're interested in. We're not interested in any part in the middle. We're only interested in the length of each of these lines. Well, we can clearly see that this one's 4, this one's 3, and this one's 7. But this one on an angle is a problem. So we need to find the length. So first we find the points that are at the end of our line. And we go, this one here is -1 and up 3. Or up 2. This is our origin, our 0, 0, 1, 2. And this one over here is 2, -1, over 2 and down 1 unit. So to find this, we need the distance formula. Now I started out with this problem for you because you need to see that the distance formula is super important. And showing your work from the distance formula is also very, very, very important. You can't get by with counting for this. It might look like 1, 2, 3, but it isn't. You'll see that it's a lot longer than that, even though it looks like it's 3 squares. You can't count for a diagonal line. A equals -1, which is our x, minus 2, which gives us a -3. B equals 2 minus a -1. When you subtract a negative, it's the same thing as adding a positive, which is right there, which is 2 plus 1, which is 3. -3 squared plus 3 squared gives us 9 plus 9, which equals the length of our line squared. The length of our line squared. Now, if you're struggling with the distance formula, there is another relearning for that specific standard early on in our semester, and you can go back and take a look at that, and it'll explain the distance formula in more detail. But here, we're looking at 18 equals c squared, and then we need to take the square root of both of those. Square root of 18 equals c, and if we were to plug that into our calculator, we'll see that this is 4.24. 4.24. If you don't know how to plug it into your calculator, you can also see me personally and I'll be able to help that because each calculator is a little bit different. But you can plug those in to be able to find the square root. Once we find that distance, we take all of these numbers, 4, 1, 2, 3, 4, plus 3 down, 1, 2, 3. The length of this line is 7 units, 1, 2, 3, 4, 5, 6, 7, plus our diagonal length, which is way more than 3. It's 4.24, and we add those all up and we get 18.24, and we don't know the units, so we just write units. We didn't square anything. We're not interested in the squares, we're just interested in the edges, so it's called units. The circumference on here is also the exact same thing. We're taking this circle and we're looking at the edge of our circle. Circumference equals the edge of our circle. So when we do that, we're not interested in any of the squares inside. We're interested in only the circumference, the edge that we have in here. So we need to find the diameter first. So if this circle gives us a center point, they don't always, but if you go the longest line in here, we count that 1, 2, 3, 4, 5, 6, 7, 8. Our diameter is equal to 8. That means our radius is half of our diameter, which is 4. The center of the circle to the edge is our radius. The formula for circumference, which you should memorize, is 2 pi r. It's not 2 pi r squared. There's no squares we're interested in here. We're just interested in the edge. There should be no squaring anywhere in this formula. When you do that, we have 2 times 3.14 times our radius, which is 4. And if we multiply that out, we get 25.12 units. So if this were a string and we had this all the way around our circle, if we were to make that string long, it would be 25.12 units. If this were centimeters, then this would be centimeters, inches, whatever. The perimeter here is, again, we're interested in only the edge around here, but now we have a curved surface as well as a diagonal surface. We have our straight edge, so we can count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Now we only want to go to this height because it begins to curve. It's not a full unit here. So this is 9 units high. This, our radius from the center out, is 3 inches. However, we can also see here, 1, 2, 3, 4, 5, 6. Our diameter is 6. That means also our radius is 3. So it's a double check. Just because this is on an angle, it doesn't mean that this isn't the same value and this isn't the same value. Any point from the center to the edge is a radius. So we need to take a look at this diagonal line. So this diagonal line right here, we need the points at the end. So this is 6, 9. And nicely, this is in the origin, which is 0, 0. So A equals 6 minus 0, which is 6. B equals 9 minus 0, which is 9. 6 squared plus 9 squared equals our length of our line, which we're calling C. Just to remind you, this is called the hypotenuse, this long line that we have here. So we have 36 plus 81 equals C squared. 36 plus 81 is 117, equals the length of this line if we were to square it, means multiply it by itself. But we're not interested in squares, we're interested in the length of the line. We don't need the squares, we're talking about perimeter, so we need the length of the line. We take the square root of it, plug it into your calculator, and the square root is 10.82 equals C. That's the length of this line right here. This length, mind you, 10 times 10 is 100, 11 times 11 is 121. This value should be between 10 and 11. Now we can add it all up. So we have the, oh wait, we don't. We have the 9, we have the 10.82, but we do not have the circumference up here. I'm going to just come right over here and do the circumference of this curved surface. We need to know the length of this line, and in order to do the length of this line, we need to use our circumference, which we used up here. C equals 2 pi r. 2 times 3.14 times 3. But we do not have a full circle. We have a half of circle. When we used a full circle, we used the full formula. But here, we use a half of a formula. So when we multiply that, 2 times 3.14 times 3 and divide it by 2, our length of this line, if we were to make it tall, would be 9.42 to put it into our calculator. So now we have all our values. We have 9 high, which we can count because it's straight. We have 10.82. We figured it out because we have to figure it out because it's on an angle. And when it's on a curved, we have to use our circumference. So our total that we have in here is 9.42 plus 10.82 plus 9 equals 29.24 inches. And we never square it because we're not interested in squared, we're interested in the length of the line. So therefore it is, our answers are not squared. We're looking at area on the back side here, area. So when you look at this, you're like, oh man, more diagonal lines. If we were thinking about perimeter, we would have to know what the distance of these lines are. But we're not. We're interested in area. And when we're looking at a four-sided figure, we're interested in only two values. Only the length of this line and a line that's perpendicular to it. Right here. Because remember, our perpendicular line is what tells us what two numbers to multiply together. So if we were to count these out and look at this, the bottom is 13. Right here is 13. And this is 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But it also makes sense. If we were to subtract negative 9 minus 4, we would also get 13. It'd be a negative 13, but in the same regards, our distance is always positive. But you can just count them when they're flat. When they're straight lines here, we can count those right up, and if we were to count our squares, we would get 7. So we're only interested in here, when we have a parallelogram, the formula is base times height. So our base is 13, our height is 7, and that equals 91. Now, if you didn't see this straight away on your test that you have to do, your retest, you can figure this out as a little triangle here and a little triangle here, but you'd have to keep track of how long your line is in order to be able to, for those little shapes. You can break it down into composite figure, but really for a parallelogram, it's base times height, which is 91. The area of a circle is pi r squared. Now you need to memorize this. Truly, you do. It's a very common formula. But we have to figure out what our r is. Our pi is 3.14. We should be very good at that. Now the scale on this is a little tricky because it has little boxes in between. But 2 boxes equal 1 unit. See how that's -2 and a -1, but they also have the half mark in here. So if we were to count those, we would count the hashes. 1, 2, 3. 3 units to the center. 1, 2, 3. 3 units to the edge. So this is our center, which is our origin, which is 0, 0. And our radius is equal to 3. Our diameter is twice our radius, which is 6, and that's all the way across, and the radius is halfway across from the center out. You can see that that is 3. So we have 3.14 times 3 squared, and multiplying that out, we would get 28.26 units. Now, this is squared, so this has to be squared as well. This is squared, so this has to be squared as well. The area of a triangle, this has been interesting for me because of making sure that you understand this, that this wasn't as clear for this. But what we're going to look in here is we're going to look at the area of a triangle is 1/2 base times height. So again, you can choose any side as your base. And the point across from it drops down, it's perpendicular. But why make life difficult for yourself? So I'm going to choose this one up here as our base. It's flat. It's easy to count. 1, 2, 3, 4, 5, 6. So our base is 6 units. Now, this line is obviously not perpendicular. It is on a slant. So we're going to go to the point farthest away, go all the way down, and it's an imaginary line. Even though we see it in here, it's an imaginary line, but it goes to, we want it perpendicular. So how many units are we away from our bottom line here if we're perpendicular? So if we were to count this out, it would be 8, not to get confused, this would be 8 units. So 1/2 of 48 equals 24. Now we have 2 more things that we need to do in here to make sure. Now this irregular polygon becomes very important, especially in the second semester when we look at different things that we need to look in here. But irregular polygon means that we're having each of the sides exactly the same. Now we have our hash marks in here, and the hash marks tell us what we need to do in here. They tell us that those hash marks, that these lines are all the same. But really, it also says it right here in our definition. When it says it's a regular polygon, all the sides are the same. This right here is an apothem. Most importantly, we're looking at this right here. That tells us what 2 lines to multiply together. So, but how is that helpful? 10 times 3 is how does that work so that they're all in here, all the figures? Like 10 times, it's 30 squares. Okay, it could be that we're making 30 squares in here, but it's hard to see. Really, we're making 15 squares inside a triangle. Oh, now we see that we're working with a triangle. Now that's important. So we're going to have one triangle is 1/2 the base times the height, 1/2, and our base is 10, and our height is 3. So this gives us 15 meters squared. So in here we would have 15 squares, but this is a very small part. We have all this other part of the figure that we need to do. How do we figure that out? Well, we break it down into shapes, just like our composite figure. And when we do that, in here, we see that all the triangles are the same. They have the same height, they have the same base. So this one here is 15. We'll call this figure 2, figure 3, figure 4, figure 5. So figure 1 is 15, figure 2 is 15 meters, figure 3 is 15 meters, figure 4 is 15 meters, and figure 5 is 15 meters squared. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 5 triangles. We have 5, and they're exactly the same. Well, whenever when we have more than one in here, we call those multiples, and we can take our 15 times 5, which gives us our 75 meters squared. So when we're looking at this here, this 5 right here, you might have seen me write on your test that there are 5 triangles. If there's 5 sides, 1, 2, 3, 4, 5, we can make 5 triangles. We take the area of one triangle and we multiply it by the number of sides. So if there were 10, 8, 20, 400 sides, we'd find the area of one triangle and we can multiply it by the sides. This right here is a composite figure. So if we're looking at this here, we're going to break it down into shapes. We have 1, 2, figure 1, figure 2, figure 3, and this little triangle will be figure 4. So when we're looking at it in here, figure 1, we have to know the length of our sides. 1, 2, 3, and 4. 1, 2 is our base or our height, and we have 2 for our base. 1, 2, 3, 4. So what does that tell us? There's 4 squares. There should be 4 squares here. 1, 2, 3, 4. We can see that that's exactly true. 1, 2, 3, 4, 4 squares. So we only use 2 numbers because we only need to figure out the exact number of squares that are in here. Number 2, it's a little bit more. So we're going to do our base times our height. 1, 2, 3, 4, 5, 6. There's 6. The length of this line right here is 6 units. 1, 2, 3 units up. That's 18. We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There is 18. 3, we'll find the same thing. It's 2 pi and 9 over. Now, when we're looking at these numbers, they don't have to be in exact order because we're multiplying. So we can change the order as we wish, but it's still 18. If we were to count these, we would get 18. And then number 4 is half, 1/2, the base times the height. The base here is from this point over. We're doing the length of the line. So this is 1, 2, and 3, and then 2 units up. 1/2 of the base, which is 3. The height is 2, and this gives us 3 units. Units squared. They're all units squared because we counted the squares. So when we look at this here, we're going to add up all these numbers. 4 plus 18 plus 18 plus 3. Each figure, the number of squares inside each figure, and we get a total of 43 units that are squares, squared units. So that's the gist of the regular the figures on a graph, especially for area. We're looking at area, which is different than perimeter, which is perimeter and circumference are similar. Perimeter is all the outside area and circumference is only the curved surfaces, but we're figuring out what numbers we need to use from the graph.